fork join pool, and also like multiple those threads won't wait for each other, like they won't block, and they won't block for each other. So let me give a example maybe. So we can create a class test parallel string, but basically the syntax is still the same as the stream API. So those methods are still the same, like map or filter or collect. Those are still the same. Remember the third parameter we mentioned in yesterday's stream API, like for the stream API, the third parameters, the third by consumer is kind of useless, but it will be useful in the parallel stream, because in parallel stream API, we have multiple threads. So we have to join the result from each thread. So here, let me first maybe create a list of integer. Just I just randomly created some integer list, and so we will use the parallel stream to first, in the first step, multiply all the elements by 2, and then we will filter like the element after multiply by 2, which element will larger than 5. So this will be 2 steps, and let's see how will the fork join pool, eternally fork join pool will handle the drop for us, and how like the step 1, all like if we have multiple threads, then they will have multiple step 1 for each of the thread, right? And we will see that the step 2, all the step 2 must will not be mandatory to all come, will not be mandatory to come when all the step 1 finished. Like each thread finished thread 1, it can enter the step 2. So let me try to do this. So we use the parallel stream to create a parallel stream object. So you should, let me check the return type. Oh, still like using the stream object, but eternally it will using the fork join pool to handle the drop. So here, let me first just map the original elements and multiple by 2. And later, let me do the filter. Like let's collect it. Maybe just use the, oh, if I just use the collector, maybe it will not sufficient for me to like illustrate what the third parameters like we met yesterday, like the third by consumer. But maybe let me just customize it. Like I create a new linked list, and maybe let me just import all the things. Okay. And also we have the second by consumer is how like we want to accumulate in each worker thread, how like we want to accumulate our elements into this linked list that's supplied by the supplier, right? So we will have a result and elements. We just want to restore x. The third parameter is that we met yesterday seems to be useless. Like the first parameter will be the final result set, and the second parameter will be the result from each worker thread, like from this worker thread and from this worker thread. So the behavior will be just we will just use like the a one dot at all. It will just accumulate all the results back together. So this is the parallel streaming. And so you see the syntax is quite the same. And we can, oh, sorry, I didn't print out anything. Okay, you see it has multiple all the elements by 2 and then filtering it. Also, let me further print out something so we can see that these 2 steps are not like mandatorily to be like we have to all the thread finish thread 1 and then they just then all of them go to the step 2. That is not the case. Like any one of the thread who finished the step 1 can go to step 2. Let's also maybe print out something to illustrate that. So here we can, oh, I think the syntax is kind of messy now. Let me go back. We can system out the current thread that working on this step and also print out this is step 1. So get name. So maybe just say that work on step 1. And also we can do the similar thing here. Copy paste this. And then let me run it. So you see, eternally, our parallel stream API is using the fork join pool to do the job, right? And also you see there are worker 7, worker 13, worker 9, so and worker 5. So there are like 1, 2, 3, 4, 5. There are 5 different worker thread, right? Yeah, there are 5 different worker thread. And you see this worker 13, at this moment, only worker 13 finished the step 1 and it directly go to the thread 2, and other worker thread haven't finished the step 1. Like it's not all this thread have finished the step 1, but anyone who finished step 2 can just go to the step 2 to do a job. And also, yeah, this is you see other thread is the same. Like whenever anyone finished step 1, just go to the step 2. We do not need to wait all the thread finish the step 1, then they enter the step 2 together. That is not the case. And also the reason why we want to using the parallel stream is that we want to achieve we want to improve the performance, right? If we just block all the thread to wait them finish one step and then go to the next step together, then our performance may be no better than a just single thread, right? So this is parallel stream. It will using the multi-threading to improve the performance compared to Stream API. So, and also this third parameter, now it came into play. So you have to define the uh, define the rules that how you want to accumulate the result from each worker thread into a final list. So let's see if we statically modify this behavior. So now you see the result is 6, 8, 10, 12, and maybe let me slightly modify the behavior, like just to make L1 equals to L2. Then the final result will be the last worker thread that who are trying to do the collect state, right? So it should not be 6, 8, 10, 12 again. Let me try to run it. You see this become empty. So like maybe some of the thread after working on these two steps, there is no element left in it. So it got empty. Maybe let's run it multiple times. I think the sequence um, is not always the same, but yeah, I think maybe let's just modify it back. So now you see this final step will be useful in the parallel string. Okay, so any questions related to the parallel stream API, or if you have any questions, just feel free to ask. If no questions, then we can like move to the next Java 8 new features, which is called complete build future. Is the order guaranteed to be the same? You mean the step, all the worker thread working on step 1 first and then go to step 2? Is that your question? The list order. So, yeah, that is a good question. I think it should be, yeah. Otherwise, we will mess up the order of our list. Yeah, I think there should be, yeah, this is a good question. I never be cautious about this part before. I think, you see, no matter how many times we run our program, this order, because I never think about like this will change the order. Yeah, I think the order won't change. So yeah, you give me a good hint. Like I think this at at all at all stage, maybe it should follow some sequence. So that is also why the reason like every time we do this, it got the same result, right? I think the add up should like maintain the formal order. Otherwise, it will just mess up our list, right? Yeah, I think that is a good point, but I'm not sure I'm 100% correct. So if I make some mistake, please correct me. But I think you see, um, every time we run it, it just give us this empty list. Let me. So I think there must be some order for the collect state. Yep. Let me change the order like. So in this case, I just provide all the elements larger than 5 so I can see whether the order has been remained or not. Like this, randomly number, then run the parallel stream API. Yeah, the order is always the same. And I think this is required because if you just mess up my list, then it's not a good idea to use parallel stream then. So I think the order should be maintained in the list. Yep. And so actually when you use the parallel, I think like the behavior, the result when you use stream API or use parallel stream API, the result should not varies. So the parallel stream API using the fork join pool to speed up the performance. Yep. And any other questions? So okay, so if no other questions, I think we can go to the next topic, which is the completable future. So let me write it down. Completable future. So we have met future previously. This future object when we using the thread pool, right? Let's see if I can find, yep, here. We have already seen the future object previously. So then why we need the completable future? So we can use the future to get the result from our thread pool, right? Like when we use multi-threading, we can use future to acquire the result. So why we need completable future? So does anyone know what is completable future and like what's advantage of using the completable future compared to using the future object? Mm, any answer to this question? Like, have you guys ever used completable future before? Yeah, that's correct. Like that is a good answer. The completable future enables the asynchronous executions. So remember that when we use multi-threading, actually what we want is we want fully asynchronous, right? We want we want all the worker thread just run in parallel, that they won't block each other. So if they just block each other, like wait other thread to finish something and then I continue doing my job, then actually this performance is no better than a single thread, right? If you constantly block your like main thread or other thread, then the thread just need to wait other thread to finish some job and then I continue. Then you can just use single thread. Like it obey our idea to use a multi-threading, like to do all the things in parallel, do not interfere with each other. So like when we use the future object, although we are, let me see here. Where's the future? So 1 second, let me find the code. Oh, here. So maybe let me borrow this. If you see the code from yesterday's session, like when we use the future, there is a method called get. Like we can only get our results using, we can use only get required results from our future object using the get method. But remember, this get method is a blocking method. That means your main thread will be blocked here until the worker thread finish the job and the future object, when the future object is ready, and then your main thread can, after it acquire the value from the future object, after it get the value from the future object, it can resume the following steps. But actually, when we're using the multi-threading, we are trying to achieve something called fully asynchronous. So we want our worker thread just do its job, and when it finish something, it returns some value. And then if we want to further operate on this value, we just want to achieve something like let the worker thread to like continually working on this value, but our main thread should not be blocked here. Our main thread should not interfere with the worker thread. So for example, here we are maybe let me submit a int value. All right. So here, let me submit a callable who will return a int value, maybe return 10. And also let us make this thread to sleep for a couple of seconds. So maybe make it to sleep for 2 seconds. And let's just use the try catch block, handle the exception. So here our callable task will first sleep 2 seconds and then return 10, integer 10. And what we want to do is this first step is like to maybe the first step of our multi-threading work, multi-threading task is to produce one integer value, and then maybe the second step we want to multiply this value by 2. So I just write some very easy logic. So maybe you can say, I can just directly multiply the value by 2 by here, multiply the integer 10 by 2 in here. But actually, I just want to explain the idea that if we have some logic that run before the future.get, and later maybe we want to like perform some further operation, maybe send some request based on the returned object. So with the future, what we will do is like in this example, like we want to multiply the 10 by 2, right? So as the second step, here we'll get the maybe int, just randomly name it. And then we want to just maybe I want to submit it again to the execution pool. So let's see, doing something like this maybe. So here we will invoke runnable to system out, so multiple by x. Okay. Let's see. Oh, we just void. I think it's the typo. Let me check. Capture, because this should not return anything. Maybe just use the wildcard, or to not even provide the variable type. Yeah, I think this should work. So you see, in the first step, we produce an integer value of 10, and in the second step, we just get the value and multiply it by 2. But here we are using the get method to get this integer 10. So if we run our method, you will see, maybe let me run this part. Maybe I should print out something here. So in order to see system out, start sleeping, and, yep. I think how can we like show that the main thread is being blocked? Maybe here. After the future, after the main thread get the future object, get the value from the future object, we print out something like resume running, something like this. And we can try to run it. You see, it starts slipping, so that means this step is start to work. Our worker thread is start to work on producing the integer 10. But our main thread actually is blocking here, keep waiting our worker thread to finish the producing. After it produce, like after 5 seconds, it produce the integer variable 10, and then our main thread can resume running. So actually, what we want is to achieve fully asynchronous, right? So what we want is that your worker thread should work after it produce the variable 10, and you should just continue the next step, maybe using another worker thread or the same worker thread to multiple the value by 2 or doing the next step logic. But with the future, actually we have to block our main thread. So it's not like a fully asynchronous. It violates our idea of using the multi-threading, like try to let the main thread to work in parallel with our worker threads. So this is the advantages of using the future. So you see this like is a blocking method. It will block your main method, just like the join, just like the join. So how did we achieve the fully asynchronous? That is to use the completable future. So with completable future, we can achieve like fully asynchronous. And that means if we have multiple steps of like, we have step 1 that producing some value, and then we want our multi-threading thread pool to continue working on the thread step 2. Then if we are using the completable future, we will not block our main thread until, like, if you force to use some like method of join, like completable future dot join, then because you see they are fully asynchronous, right? If you do not, like at the end of your main thread, you do not let it to wait for the completable future to finish the job, then the main thread will just end itself, and then we can never see the result from the completable future. So at the end of the main thread, like when the main thread finish all logic, you still have to like make the main thread to wait for the completable future to join in order to see the result. So let me give an example. This is the, maybe change it to that test future. Then let's further create a class test completable future. So with the completable future, let me first create a completable future. By using the completable future, you do not have to like create a thread pool by yourself. Like there will be a default thread pool provided by the completable future object. So maybe let's check the constructor of completable future. I think I remember when we define the completable future, we can change the default thread pool. You see, returning a new completable future that is asynchronously complete by a task running in the fork join pool. So I think this this supply async, that you will supply some task to your completable future, just like you submit task to your thread pool, and it defaultly using the fork join pool, like the multi-threading pool, to do the task for you. But I remember, yeah, you see, this supply async method is an overload method. So you can provide your customized choice of thread pool. So as the second parameter, like executor. So this will be, remember that we have seen met a lot of executors, right? Those different types of thread pools are the subclass of interface executor. And so we can provide our customized thread pool to finish our task. But if you do not provide any thread pool implementation, then it will defaultly using the fork join pool to do the job for you when you supply the task into the completable future. So here, what we're gonna do is we want to convert our implementation, like from using the future to using the completable future. So here, what we're gonna do is like we will use maybe here. Let me do integer. The same. We use the completable future.supply async to supply to produce uh, the initial value integer value 10. So here, let me just do something like this. And after that, we can see that we can system out like in the main thread. We will check that, and later we will like then accept, like we will continue after it get the value 10. We want our computable future to further multiply the 10 by 2 as the second step, just like the previous example. So here, let me just then accept. I think this should work as this. And the then accept will receive a consumer. So it does not return anything, but just consume the value that we are produced. So here, what we're gonna do is let's just maybe try to system out the next step. And also, let's just multiply the x by 2 and print out it. So here, maybe one thing, let us also to make the first step to sleep for maybe 5 seconds in order to make the result more clear. So here, let me borrow the code line here. So you see, in the first step of our completable future, it will sleep for 5 seconds and then produce an integer value 10. And later in the next step, we will accept this integer value and then multiple by 2 and print out it. Also, in the middle of our main thread, like between these two steps, it will system out something. So you see, the main thread will just system out, and if we do not like even using the join, I think the system just print out and finish, because you see this is fully asynchronous, so the main thread does not interfere with the completable future worker thread. So the main thread just finish itself because it has already finished all the job of the main thread. So here maybe we have to call the join method. So in this case, this is a blocking method, right? We can block our main thread at the very last statement of the main method. So in this case, you can see the main thread just to finish a job, and then you see the worker thread is still working on it, and then after it's produced the value, it just print out the 20. So in this case, it's clearly we can see that the main thread does not get blocked by the computable future. So actually, what you are actually doing here is you just define what the worker thread should do step by step, and actually like there is no um, there's no any relationship like between the main method and worker thread. They just working on each other's job individually, separately. So, and also you can see something like we're still doing something similar to using the stream API, right? We are using some chain operation. You see the then apply. So actually what we can do is we can even move this part. Maybe let me first and then comment out this part to see what. So remember that those this completable future work separately in parallel with the main thread. So we can just define um, all the steps, uh, all the procedures in one statement using the chain operation like this. Just similar to, let me see, what is the problem? Completable future integer. Oh, here. Because we have now changed it to the chain operation. So you see, at this step, it returns a completable future of integer type, but actually after all the chain operation, it should just return something called void. Or not void, provided void. So the type should be, maybe just remove all of this. Let me see. Provided void. Oh, I think that is the case. But I don't think there is a difference like I write drawing here or just directly. Oh, I see, I see. So the last step, if we just use the join, then we should not return anything at here because the join method does not just return a void, but not the completable future. So you see this, now this is the result that returned by the then accept method. But if we change the join also here, it should be the return type of the join method. It's not the completable future, it's just a void. So if we want to add join here, we should maybe just change this. Like we do not want any return type. We just want to supply the step 1 and then chain operation to step 2 and then let the main thread to wait for our job to finish. But I think if we read join at here, then it should block our main thread. So maybe it's not a good idea to block your main. You see, it block your main method. It's not a good idea to block your main method before it finished all the things. We want the fully asynchronous, right? So just you see, this is we just mimic the logic doing by the main method. So here is some maybe other logic in main, and then at the very last of main method, we just let the main method to wait for a little bit for our completable future to finish its job. Now we can run it. You see, it start producing and our main thread had finished. Like, let me further system out. Like you can do some logic in the main, then system out. Main has finished all the work, all the work. Try to run it. You see, start sleeping, and this is in the worker thread, and in the main thread, you already finish all the work. Just to use the join to block to avoid main to finish itself, and then you can see finally the worker thread has procedure to the next step. So this is why we want the completable future. You see, compared to the future object, we achieved fully asynchronous, and also completable future provides something similar to the stream API. It is the chain operation that you can just use the dot, then accept, or many other method. Let me try to see, then accept, and have complete, or many method. Like maybe I also have like something like then combine or then run. So those are all the chain operation method provided by the completable future. You can just use the dot and method name to chain the operation of all of the completable future. And this can make your code like more neat and readable. So also, besides this chain operation, I also want to introduce one uh, commonly used method in the completable future, that is called all of. So besides that, just achieve the fully asynchronous and the chain operation, also the completable future provide you some other features like to combine the results from multiple completable future objects. So you can use all of, or you can use something called any of. Those are different, like all of, just as the naming first. If you have a multiple completable future working on some work, or working on some, maybe sending some request, and you want all your worker thread to proceed to the next step 2, when all the requests get response. And you can then use the all of method. So when you use the all of method, the your completable future will wait all of them to finish, and then gather the results to the maybe process all the response in the next step. And also you can have something called any of. So if you use any of, then the worker thread like won't wait for all of them to finish. They just whoever finished step 1 will go to the step 2, just similar to the, if you use any of, the behavior will be quite similar to the parallel stream API, right? You see the step 1, any one of it finish step 1 will go to the step 2. So if you use any of method of the completable future, then the behavior is kind of similar to the parallel stream. But if you use all of, then it will block until all of the thread finish step 1, then go to step 2. Maybe let me give an example, like first come out all of those. And we can do something like, why there's no retract for my, why the format is not correct. So let me try to come up with the example. Like first, we want to have a list of completable future. Like we'll just simulate that we have a service that trying to send multiple requests to maybe some other API, some downstream API, and then we will try to gathering out all the results from all of this completable future objects. So we want to create a list of completable future, and just name it as completable future list. So how we gonna create it? Maybe we can use something we learned from yesterday, like we use the stream API to, instead of using a for loop to create this completable future. Like if we use the for loop, we will doing something like this new, oh sorry, it's lagging, okay. If we use the for loop, we're using something like this for int I equals to 0, I less than 10, maybe 5, then I plus plus, and doing something like this. We keep adding completable future object into our list, and then doing something like this. But because we have already learned stream API, right? So maybe let's just change this for loop implementation into a stream API implementation. Like we can use int stream range close range. So this will create an int stream that from the range that you define. Maybe in this case, I just from 0 to 4 because it's a close range. So the 4 is inclusive in our int stream. And later, what we can do is we can use the collect. So here we're gonna collect the result. So let's just use the customized way. Like first, I use the supplier to supply a new linked list in order to contain all the completable future object that we are created. So next step is the behavior, that how we want to accumulate our completable future, how we want to generate our completable future, and then add it into the linked list, right? So I have a rest and every element in this int stream, that is the integer. So remember, this x is the element from the int stream, right? Is the 0, 1, 2, like 0, 1, 2, 3, 4. So this is the x. Maybe will be each of them. X will be each of them, like each of them. So here, what we're gonna do is we will try to create like new completable future, and then also, oh no, maybe we do not do it in this way. We use the completable future supply async method to create a completable future object. So here, what we're gonna do is we have to provide a supplier here, right? So the supplier, remember, it does not take anything but return something. So here we're gonna return maybe, let me just return a random integer value, maybe just return x. And also here we're gonna system out something like this is the step 1 of request plus x. Okay, it should work. Then the final thing is the third parameter, that in this case we're using the parallel stream, so the third parameter is kind of useless. Just to use something maybe, and then just leave it to be blanked. And oh, sorry, I think I read it in the wrong place because the formats, yeah, it should be here. All right, check. Yep. So this is the first step of our list of completable future. So you see, we are using the stream API just the same as the for loop, like for loop from 0, 1, 2, 3, 4. And then in each of the iteration, we are trying to create a request by using the supply async. So each request will be handled by one completable future object. So we are creating 5 completable future objects, and we add each of the completable future into our list of completable future. So now we have a list of completable future that's doing sending the request. So this is stimulates that we are sending a request. And then what we're gonna do is we want to wait until all of the computable future finish the request and get the response. So this is the response. And then we can move to the next step to maybe further operate on this returning value. So what we're gonna do is we have to use the all of method in order to wait all of this computable future finish and then to the next step. So here we're gonna create a computable future object. So this object is like a dummy computable future object. It does not contain the actual result, but it used to indicate whether all of the result has finished or not. And also, you see, we can use the computable future, the all of, and then this, you see, this method, the input type is an array. So this 3 dots is the same as the bracket, that the array. So the input type should be array, but now we are using a list. So we need to convert our computable future list into an array. And here we have to specify the array type. So here we're gonna, this thing is, let me check. Oh, no errors. So this part is just to specify the array type, nothing special. And all of them, this part is just using to convert. Let me write some comment here. The all of only take computable future array of completable future. So we have to make it to array. And then also this CF variable does not contain the actual return value. You just use to signal that whether all of the results all of the request has finished or not. So how can we proceed if this completable feature does not contain the result from the first step? Then how can we like work on the returning things? So that is, we will use something like cf dot then accept. So when this cf using the all of method, it detects that all of the request has finished, then we can use the then accept. So remember, this is just a dummy computable future, so it does not return anything. So the input should be, when we use the then accept, the previous returning should be a void. And then this then accept take consumer, right? So when did we proceed on those list of computable future, and now is the array of the computable future, is that in this consumer method, in the method of the consumer object, we will like loop through this completable future list one by one to proceed. So we are not directly getting the results from the CF object. Actually, we are directly looping through this computable feature list to do the further steps. So here, what we're gonna do is, let me think. We should move to the next stage. Maybe just doing some dummy logic, like for example, I want to still using the Stream API to handling this job because we have already learned Stream API, so we should use it whenever we can to enhance our skills, right? So here we can use the .stream and so remember, this is a computable future list. So when we use the .stream, then the stream contains all of those completable future object. So we can use, maybe just use for each, then provide each of the completable future, maybe call it completable future, but this name has already used. I think I'd have to come up with another name, maybe just call it response, or the name is ugly, maybe just random name it. So here, like, we will use the X is the completable future, right? We will use the, maybe use the then accept of each of the completable future. And then because we are taking the change and let me change the reference name, because I want to continue working on this X. So maybe if I use the variable X here, we'll make a little bit ambiguous. So here, this is X. Although the name doesn't matter, but I just want to use to make it consistent for easy understanding. So here we're continually working on the returning value X, and we doing something like system out. This is the step 2 of request, maybe X, and then we're gonna maybe further system out something like the final result. We want to multiply this X by 2, doing something like this. And I think, what did I miss? So this is to stimulate. Let me see. What does it say? Oh, cannot be applied to. Oh, I have to convert it into int, maybe. Yep. So here you see, we are using all of to try to accumulate the response from all the requests that we send, that our sending request will returning an integer value. And then after all of them finished, we're using this completable future to detect whether they are all finished or not. So if they're all finished, then this completable future will do the then accept step. And but this completable future object, the CF variable, does not contains the actual value. We have to actually loop through the completable future list again and get each of the completable future objects inside it. Then we proceed on the task. So proceed on the step 2. But like the stream API actually is no difference for just using a for loop to loop through the completable future list, the list of completable future. So I just want to, like, because we have learned it, right? So just use it. And let me try to run the code. Oh, I forgot to let our main thread to wait, because it's fully asynchronous, right? So we have to make our main thread to wait until this logic finished. So see, when we use the all of method, it waits all of the working thread to finish the step 1 and then going to the next step, like the final results. You see, all of the step 1 finish and then go to the step 2. And also, you see that if we are using the stream API, then this result is kind of in order, like result of request 0, request 1. Like if I run it again, you see. So this is as our expected, that all of the thread step 1 has finished, and then we go to the step 2. So, but step 2 is kind of in order, like 0, 1, 2, 3, 4. So it's kind of using the single thread to finish the job, right? So if we want further to make those list of computable future to be fully asynchronous, maybe we can use the parallel stream, right? So if we use the parallel stream, all the syntax is the same, but it's using the fork join pool to proceed on the to conduct this task for each state. So you see, the step 2 does not follow any order. Just maybe the request 3 finish the step 2 first, and then request 4 finish step 2. You see, but still, the step 1 should finish all of the step 1, then proceed to step 2, because we are using the all of method. Actually, if we use the any of, you will see the difference. So if we're using any of and then run it again, you will see something like, you see, oh no, that should not be, because the step 1 just finished too quick. Let us make it sleep for a couple of seconds. Try thread sleep, maybe make it to sleep for different times, like x multiplied by 1. So in this case, the task 0 will sleep 0 seconds, and task 1 will sleep for 1 second. That thread 2, task request 2 will sleep for 2 seconds, so on and so forth. So here, then their step 1's finishing time is not the same, so we can see did I miss something? Why just finish this off? Oh, try. I think it should, the cf.join should wait all of them to finish, and then it should not just like, is there something weird happened? Let me check my code. Like, because that's kind of weird. That is like when our request 0 like finished the step 2, and then it just the self just directly go there, called .join, and then join the result, and then just maybe let me further do one thing, like make each of the task to join here. And I think this should let us see the results, maybe. Let me think. And in this case, I think it should use parallel stream. So otherwise, if we just use the stream, then it's a single thread. Then when we join, it will block other task to do the step 2. So let's run it again. You see, now when we're using any of, this step 1 is not like required to let all the worker thread to finish step 1, then go to the step 2. It's different from all of, right? Any of, just as the name inferred, any of the thread who finish step 1, just go to the step 2. So you see, some of the thread has not finished the step 1, but any one of them who finished step 1 can go to the step 2. So this is the all of and any of. You can use them to combine the list of computable future. So okay, yep, I think that is all the things that I want to cover for completable future. So do you guys have any questions related to the completable future part? So um, we can take 10 minutes break from here and let's meet at, if you guys do not have questions, let's just stop here and resume at 11:20.